So thank you for being here. I'm ALBERTO Salazar. I'm with a huge jet lag because I live in the other side of the world. I mostly work in the Latin America market, and I also giving consulting in several banks in US and Switzerland too. I'm the CTO and the director of Advanced Latam, who is a consultancy company who works almost always in open source projects or put a hand in the open source projects to help all the customers that we have. So before start, how many of you are using microservices at this time? A few. How many of you are using serverless or function as a services in the cloud? Almost nobody. David. How many of you are continue creating monolithic applications that use an application server? And the other one? And the other ones are doing mobile, JavaScript. Okay. So first, I start to speak a lot in the last 5 years. I spent traveling around the world. I given talks in Asia, and now in Europe, and in Latin America almost every month, and in US. This year, I launched a book that is about the Spring 5, and take a lot of examples in the new ways to create architecture using the last version of Spring. And in this year, I also granted as a Oracle Groundbreaker Ambassador, that is the ex-Dev Champions program of Oracle, and OutZero Ambassador too. And I'm also a Java user group leader and founder of the Java user group in my country, and also the organizer of a Java Day conference in my country too. So what is bothering us today or now? We have several tools. It's a wonderful time to be a developer. We have several languages, we have several tools, but what is the problem? That any people is talking about microservices, other people are talking about serverless, other people are talking about the way that we used to create applications, and other people are talking in the market about tools and what is going to happen with these tools, like this is the future. But in the matter of time in software architecture, we always must take care about the context that we are creating and the age that they start the application. Everything changes in the technology every year, but we need to take care of our application, of our architecture every day, thinking about that is going to be, is going to change in sometimes the technology. So we must take care about create applications since the beginning that is going to be loosely coupled and it's going to be built in components. So what is going to show you today? I am working in several banks to move these monolithic applications. So I find a way to start to split this application that I'm going to show you. Then I'm going to give you some tips and tricks that I find when I went to microservices in productions. And finally, we are going to see serverless in action. I'm going to show you some functions as services in the Amazon in AWS and also in Oracle Cloud. So what is this monolithic? Maybe in the 2000s, we started to create these applications that is packaging as our ER files or our Word files that have a few layers, the presentation layer, the business layer, and we introduced several patterns inside. We put business delegates, we put facades inside, and it started to look simple. But what is the problem? Even that we try to avoid complexity, during the years, what happened? The team started to grow. I have more developers working in the same application. I have more projects working in the same environment. And what is happening after 10 or 15 years of the application? It's just one application that is managed message or told to each other via queues, but it's really complex to handle. It's not look with a few layers. It starts to have a really hard dependency inside. I mean, if I start to open the dependency, this is just a package dependency between years file. I even can look the dependencies that I have in the code. And what is this? This is a problem also because in these years, maybe in 2005, that bring us service-oriented architecture, many institutions or big institutions start to acquire products without thinking too much if they are needed or not. So we start to have a service-oriented architecture inside. I have several monolithics. I have several products, an ESB or a VPM inside these institutions. But the good part of this code on all these years is that they bring us, or they bring money to the business. So we are living from these projects. Even if everybody is complaining, or even if came to the organization new people to start working on the applications, they must realize that the application that they are working on, and they see that it's complex or they want to change, is bringing money to the business. So this is the good part that we need to exploit, because we are going to need money and investment to move forward this application. So what is happening? I start this application as a monolith. Maybe sometimes several of my customers also take the road of use OSGI and modularization inside this, inside Java in these years. So in this institution, I have a service-oriented architecture products. Then it's happened that some of us start to split the front end and the back end and start to create applications in HTML5. Then start this revenge of JavaScript. Why I call it that? Because I started in 2000s programming with several alerts, and then when I take JavaScript in 2010, it was really different. I have a console, I have Node, I have a debugger. So I start to create a new framework every week. And in microservices, we have now several choices. We can create our code using Spring, using a microprofile distribution, using even our application server based in a JEE a specification. And nowadays, we have several tools. We don't have just the we don't just have the code that we handle about our business. We have several tools that are going to work in a site to manage microservices. We are going to have containers based in Docker. Now we are talking about orchestration using Kubernetes. And then we are also now talking about service mesh with Istio. So it's tools that we have to handle microservices. But what is going to happen in the future? We don't know. Maybe this evolution is in evolution. We are also talking about reactive. We don't know what is going to happen later. So we need to take care about this code that is going to be modular. And what is the reality? That we have now more devices working in the market, more customers working in the market, so we need to scale our applications. That's the real problem. Our monolithic, if we don't evolve and our business is continue to be, and if our business is continue to be, is going to make a profit, that is going to happen to us. We are going to have more customers, more devices, more requests to our applications. And we finish with an environment and with a complex environment. What is this? We start to have our servers in on-premise. We start to try to use a cloud. In some cases, we start to expose several services to other customers, to other business that is going to start to interact with us. And we also start to use other clouds, so we are talking about hybrid cloud of multi-cloud environments. And what is this? We are dealing with a complex architecture. It's a distributed architecture. Even our monolith that we are talking about, the 3 layers or tiers, we are talking about a distributed architecture, but this is more complex architecture. And what is the definition? All of our applications work with messaging. And if you see just the definition of distributed architecture, we are talking about components that are located in different computers that talk with each other or communicate with each other with messaging, and it will fail independently. All of these features or characteristics is microservices. And it's also, when we start to talk about service-oriented architecture, it's the same. What is just changing between the years is the tools that we're using. So one of the problems of this architecture is that we put a wall between our applications. We now have this tool that is going to separate the domain of our business. So we start to really have a wall between our applications. In the past, when we maybe use Corba or we use AGB remoting calls, we don't have this wall. So now we must take care, we must have more care in how we are going to deal with this application, with this communication. So let's go with the microservices. We want this huge monolithic, complex monolithic application move forward. We are going to try to split it. How we do that? We try to pass from one pattern, that is the monolith application, to be split in several applications that is going to handle different kind of domains of our business. We start as a ER file or several ER files that have a database, and also we have a HTTP server in front. And we want to split it. How we are going to do it? We, in the first place, want to separate the front end of the back end. So I want to try to refactor all this code to take the business logic outside. Even if I am using an application server, what I'm going to try to do? I'm going to try to split this business. How I do that? Because like I have all these applications born in the age that we use Java server faces or maybe struts, we have inside the ER file the front end and the back end. So I'm going to try to put a wall, the first wall that's going to split these two. In the mostly of the code that we have is a Java services controller that in this case is with a framework that the name was JBossSim. Some of you listen about JBossSim in 2008, 2009? A few. It was an idea that we are going to join that we can use the AGV or session beans as a managed backend bean of the Java server faces. So you put this annotation and you start to be exposed to the to the world of the front end and the JCP. So this application is even more glue than the other ones to have the separate backend bean. So mostly of these applications always use a facade that we introduced in these years. And we have the AGV that is going to call the business logic. So what I'm going to do? I'm going to try to split this. How I do that? I'm going to put a queue in the middle. With this wall that is going to be a queue, I'm going to batch all these requests that is not going to be synchronous. I start to, and I can use any broker that I want. I'm going to need a producer of the message and a consumer of the message. An easy way to do that is to introduce Camel. How many of you know Apache Camel? A few too. It's so easy. With 3 lines of code, I said him, okay, when I'm going to receive a message, I'm going to leave it in a queue, and then it's going to take it to process the server processor that is going to be or handle this request in the backend. And easily, with these 3 lines of code and processor the message, I start to have a wall between these 2 walls. And also, what it gives me Camel? I need to apply a pattern that the name is implemented in, that is implemented in Camel, that the name is request reply. So I hide the complexity to handle asynchronous calls. And when I deliver a message in the queue, instantly he starts to process and create another queue without UC. And when the process is finished in the backend, he put a message in the queue that is going to respond the message. So it's really easy. It's a really easy way to split these 2 worlds. And what is going to happen later? I'm going to try to split this backend. Like I have now the wall that is the queue between the front end and the back end, I start to work in the back end. So I start to split this huge monolith application in several modules that is going to continue working, maybe sharing the database, but I'm going to try to create modules that had a boundary, that had a domain that is less bigger than I used to have in the ER file. How I will do that? I can use any implementation of Java now, so I can use Vertex. In my case, I use a Spring Boot that is working really well. And I start to create also a Docker file in the applications to what? to deliver the application also inside a container. So I win two things. I start to split the backend, and then I start to containerizing the application. But what I need to take care in this time? I need to take care about the logs. Like I am splitting this application, it's going to be harder to find errors. It's going to be harder to trace an error in my old application. And what I need to do? I can use logging implementation that can handle mapped diagnostic context. So I'm going to enrich the log with what? When I start a message or I start to process something, I need to use a correlation ID. So I start to create an ID that is going to be unique between all my sessions, all the business that is going to happen behind. And then I collect the logs with Logstash that is working all this code in different JVMs and different containers. I need to start to recompile all of these logs, and I can search it using Elasticsearch. So I create an API that is going to find what happened with a transaction when it started with a customer or with an ID of the transaction. So this is going to help me later in find errors without entering a problem. But then later, what I want to do, I want to take out this queue and start to run everything based in REST services. So I start to expose services and consume services without the queue. But what I win in this time, I now have boundaries of my business without break that code that is old, that is continue working. And in this time, what I'm going to do, I'm going to introduce maybe an API gateway, whatever this is, and I start to work and have microservices without too much trouble, without this evolution that they start to create a new application and to delete code or refactor code. With this queue, with this splitting of the backend, everything helps me in this time. But I start to create a new evolution of this application that is now splitted, that I have maybe an API gateway in front of all my microservices. I start to handle Logstash, Elasticsearch to find the way to trace everything in my architecture, and I start to split the data. After this, I really have an evolution of my architecture. Even if I don't move all the code, I will try to move as much as I can of this application, because some of the code maybe is going to continue being a monolithic. This is the reality of our environments. And I'm going to secure everything with what? With JSON Web Tokens, JOTs. So what happened? When I start to be in microservices, not all is happiness. What I realize, like I have everything splitted, I start to have problems on communication. It also cost me this communication inside the services. So I start to have an overhead on messaging, on communication. What else it's happened? Like I told you, trace an error. Even if you use Logstash, and even if you use or maybe an APM tool like New Relic, it's going to be hard. It's going to be hard to trace errors. And the problem is that everything is like it's splitted. I need to deal with this problem. And it's going to be hard or going to take more time to fix errors in production. And one thing else, the cost of development is going to grow. I need more tools. I need new environments. I need maybe a cloud. I need to invest also in the operation team. I need to deal with the database manager or the DBAs because I'm going to have a splitted environment of data. What this is bring me, or what problem this bring me? That I also are going to need an extract, transform, and load tool, an ETL tool. Why? Because later when they want to manage all this information or making intelligence in the business of the data, they will need all the data in one place. So all of this bring me new costs to my team, to my development team, to my operation team, and my production environments. And one thing more, if I start to split this monolith, and in banking several code is built in mainframes, is in COBOL, or they have several products that are monoliths, that they can handle some request in seconds, you are going to have a bottleneck also. Why? Because you start to scale everything that is in front of you, and then you are going to have a problem in calling the monoliths. So you must thinking also too. And one other problem, if you are not having a culture of continuous integration, continuous deployment in your monoliths, don't work or don't think in microservices. Because in the beginning you have maybe 30 projects, 40 projects, and if you are not automate all of this stack of building, can you imagine to split that code in 500 or 1,000 projects and handle the delivery of the application? You will have really problems if you are not working in continuous integration, continuous delivery, and maybe thinking about DevOps culture. But that's not all. I need to know about containers. I need to know about how to orchestrate these containers in environmental production. And in this era of microservices, I'm going to introduce is-to-service meshing to handle all of these troubles of communication, logs, and problems that we used to have in the first start of creating microservices in 2015 or 2014. Now, with is-to-mesh, we have a sidecar that is a container that runs aside of your container of your application that is going to handle failover, logs, and tracing. That is going to help you. But this is going to increase the money that you need to handle all this environment. So what about serverless? We talk about monoliths, that is complex. If we want to evolve it, there is a way. It's going to take time, but we need to have the support of the executive team of the company. Why? Because we are going to need money. We are going to need new tools. We are not going to need to change the culture of the organization, because it's not just the developers that are going to create the microservices. Then the operation team must know how to deploy it, how to handle, how to trace errors. And what about serverless? This unit of work that we used to package in a container now is going to be smaller. And like even in the microservices, we try to create the logic smaller as we can. But in the serverless, we call it as functions, a small part of create business logic. And what is the good thing about serverless is that we start to forget about the servers, about the scaling. So I can create a logic that is going to be deployed somewhere in the cloud. And when it starts to have more requests, what is going to happen? It's going to scale alone without I need to do anything. And one is the key thing that we need to understand, that is ephemeral. How many of you understand the word ephemeral? 1, 2. To clarify it with easy words, the ephemeral is something that is created and have a long time of life, and it die after this life, finish the life cycle. So what is going to happen with our function? Every time that it's going to send a message or request a message, it's going to make a call, it's going to start the container, it's going to run our function, and it's going to finish the call and download the stuff, our container. So every time. So I must take care to use function and services with the language that I'm going to handle, and maybe I'm going to show you the Spring functions, that is going, the time that is going to start the application is going also to summarize of the business logic that I'm putting on the on my code. What about vendor lock-in? Many of people who are working on serverless and function and service say that this is a problem. And there are now ways to avoid that. One of these is that I use Spring Cloud Functions. One of that is also a FM project. And what I can have with this, I can have code that I can run in different clouds. So I can exploit each cloud, or what gives me each cloud in a good way. So what is happening? We are going to move from monolithic to microservices, or we are going to move from microservices to serverless, or directly to serverless. We have many choices. So we need to experiment what is good for our business, and what is the support that I have from the executive team for I can experiment it. I can just, as a developer, I can't just take the decision to move forward. I need to work with an entire team and the entire organization to work on the culture that I'm going to move. So I'm going to end with an architecture that is moving to microservices. I'm going to have several of monolithics too in the environment. I'm going to try to use or experiment with functions. That is a good way also to do microservices, because I can create microservices forgetting about all of these things, about the container, about the orchestrated containers, about the handle the rebalancing and scale. And I finish with some code in my organization, in the cloud, some monoliths, some microservices, and I'm going to introduce you a tool that the name is Auth0. How many of you know about Auth0? Nobody. 1, 2, 3. Auth0 is a serverless authentication platform, or a platform as a service to authentication. So what it's going to give me is going to give me the security of all my environment. Also, it's the scale as much as I giving requests or making requests to the application, so scale infinite. And it's really easy. It's a really easy way to go to the three-party authentication. How many of you know about three-party authentication or OAuth 2.0? Great. Every one of you maybe are using it without knowing. It's when you start to now log in to any application and say, do you want to log in with Google? Do you want to log in with your Facebook password? Do you want to log in with GitHub? This is the standard on the protocol. And what it gives me, I don't need to take care about each social media that is implementing this. I can just connect to Auth0, and behind him, I can just check what socials networks can log in the application. So what it gives me Auth0? It gives me a three-party authentication with Facebook, with Google. It will provide me the JOTS token. And it's going to provide me also the validation of this request. I'm going to forget about this in infrastructure, because if I want to create an authentication server, I also are going to need a new server and a new implementation of that. I also can use Keycloak from the open source community. And what I start to do also, I start to create all my systems reactive. Spring has a great implementation over the project Reactor, that is Spring Webflux, that help me a lot in scale these systems, and can process without logic 10 million messages per second. In my experience, all of these microservices that I start to create are running in a data center, not in the cloud, with 1 GB of RAM, with one processor, and I have just 2 instances of that, of a small monolithic for running mobile banking and personal and corporate banking, that is the web banking, just with 2 nodes, and handle around 500,000 customers by day with a few resources. This is what is the wonderful thing about reactive systems and how it looks. It looks really easy to create applications. I'm going to go to my reactive application. How many of you create a Spring Boot application before? So I'm not going to explain that. So at a FaaS job, I have the application. And what is wonderful about that? That I'm going to create a functional router that is going to handle the request, maybe to create, to get clients, to post clients, to put, to edit clients, to delete clients. And with 4 lines, I have all my API exposed. And I need a handler that is going to implement each method. So it's really easy. My microservices looks really easy, and it's going to scale a lot. And if I want to deploy it, I can go to any cloud that is going to run. So for example, I can go to Oracle Cloud. I'm going to log in. And I create an application that is really easy. So I take that it's going to be a Java Standard Edition. I'm going to put a name up there. And I'm going to upload a zip file. What is this zip file? This zip file is just our jar file that is just created, plus what? Plus a manifest JSON. So it's our jar that is a FaaS jar running Spring Boot with a manifest file. What is this manifest file? It's really easy. It's going to say what runtime is going to run and what command is going to run when it's working. So in a few seconds, in a few minutes, I deploy my application to the cloud. So I have my microservices in the cloud. And then I can call it really easily. So I am listing all the customers that I have. And it's really fast. It's running in somewhere else in the cloud. And what else? I have my modules no blocking and using reactive. And I have function as a services using Spring Function. What did give me this project of Spring? It gives me a way to create function. In the similar way that I create these Spring Boot applications, but I have adapters to the cloud. So I can deliver this code to Amazon Lambda, to Microsoft Azure, to Apache OpenWhisk, and you can also create the new providers, and in the community are working that this code is going to run in other places. What is this function? It's really easy. So this function, what it has, the difference is that I'm going to put my dependencies of a Spring Cloud API, but I have a functional scan. This annotation is going to scan the application and is going to deploy it into the cloud. And what I need to implement an interface, a function interface of the Java 8 that is going to have an input and an output. In this case, I create a simple sample that is going to replace the string. And I need to create a handler that is going to extend the handler of the adapter that I want. So it's really easy. I just create a handler that's going to extend the adapter that I'm going to run, and then I can deploy it if I have the customer of the cloud, like Amazon Web Services here. I create a Lambda that is a function that is going to be deployed into the cloud. So if I run it, after I run it, I have it in the console of Amazon. My function that is going to change the string of an account that is deployed in the cloud, who has exposed as the API gateway of the Amazon Web Services, and I can test it on the cloud. That's a matter of time of the internet. So, like I said, the time that it's going to take is that he start all the container from the beginning, and every time that I make a request, it's going to create the Spring Boot application, is going to destroy the Spring application, and is used, how it said here, the duration of 11 microseconds, and use 139 megabytes. And what I point of that? Because later I'm going to need to know how much I need to pay for that. Every request is going to cost me. So what is the big picture about that? I finish using the API gateway. I finish using Lambda functions. I finish using Auth0 to authenticate all of this trip. And in the cloud, I'm going to see what happened with the logs of this request. This test that I ran is the last one. So I'm going to make a call of the function. Make several. You see that it's faster. And what happened with the log? I have more requests. And what is the important thing to understand here? That the report of the duration is 140 megabytes. And the duration is 0.65 milliseconds. So around 262,000 requests is going to cost me $1. Is it expensive? No, it's cheap. And it's going to take me less time to create lambdas than create microservices if I'm going to experiment new code in the cloud. It's take me a function that have an input and output, the logic that I want to give them, and it's not going to cost me a lot. So what happened with the Auth0 authentication? Auth0 is really easy to use. You can open an account, and then you are going to the dashboard. So you can create a new application. In whatever language that you want, it's going to give you a template with implementation of the libraries. It's really easy. So you can put a new application here. You can put now is the boxes. There is una poca application. I can use a template of iOS, of Android, a single place of JavaScript that use Angular, React, Vue, or in my case, like I created, I want to a traditional application that is based in Java. And I'm going to choose what template of the implementation I'm going to use. So I use a Java Spring MVC template, and I just can download the code and running in my machine. What is the key thing about this authentication, or three-party authentication? In the applications, what I really going to need is this, the handshake between my applications and Auth0. So I'm going to have the domain, the client ID, and my secret. I'm not going to give you, but how it looks, this application. It looks really simple, that implements the API of the Auth0. So Auth0 is going to create the handshake that I'm going to handle, and I'm going to add a filter that is an authentication filter that is going to create the tokens and is going to call the server to authenticate all my applications. So what happens if I run this application? Let's open this console. I'm going to run the boot application. And if I run in localhost, what is going to happen? It's going to give me the login screen of Auth0. So if I run localhost 3000, it's launched me the three-party authentication that I can log into my application with Google or with a user password that I have, and easily I handle all this stuff of security that is hard to handle in all my applications. So you can download the code and running this as a container of as on a Java application, simple. And what is this happening on all of these session? What I am dealing in this business, I am dealing with distributed complex architecture. It's not simple to evolve. And year by year, it starts to be more complex. We need to secure everything. We need to secure all of these endpoints that we are going to expose as a microservices, as a monolith application, or in a serverless function as a services. We need to deal with the communication. We saw that in the beginning, like I run the application in the internet, it's happened that like it's in the cloud, I'm going to have sometimes problems of communication. It depends of the bandwidth of the internet that I am using. I need to take care about failures. Now it's running something in the cloud, something in my machine, something in another cloud that I ran the container of a Spring that it was Oracle Cloud. And when I'm working with these modules, I always must think in refactor. When I start to create the domain never finishes, because when I start to evolution the requirements of the business, I must be prepared to refactor without fear, to change the limit of this application. And if we have a legacy system that sometimes came new people to the team, or new architects, or new developers to the team that said that this crap of this has bad code, we need to explain everybody that these decisions of the application was taken in one time with one tools and with one context of the business. That is not the reality that we are handling now. Sometimes monoliths continue to be a good way to create applications. It's not bad to continue doing monoliths, and it's not bad to continue using application servers. The standard that we are using in every application now to this interact of the messaging is JWTs, JSON Web Tokens, JSON Web Signature, which JSON Web Encryption. If you don't want to deal with that, you can use Auth0, that is really easy to use. And I finish with a hybrid approach of the architecture. I will finish not just with microservices. We are not Netflix. We are a business that must care about that the organization continue make money, continue running every day. So I will not finish with a single architecture in my business. This is what we need to realize. And we need, even if we just work in monoliths or in microservices or serverless, we need to take care about logging. So when you approve pull requests of other developers, of you working pair programming, take care about the logging that you are doing, because if the business has an evolution or making money of your applications, in the future it's going to be really hard to find errors if you don't take care about the logs. You can experiment all of these examples or your code with a cloud environment that could be Oracle, it could be Amazon Web Services, Azure. Everything gives you a trial so you can test your code and use the tools that you are comfortable with it. And maybe if your team are not big, if your development team can sit in a table and share a pizza, maybe the microservices is not for you yet. You can continue working as you are doing now, but when the application is going to have success, you can now think about the split application and start to be complex. And independent of the style of architecture or patterns that you use, you always must think your code must be low coupling, high cohesion, implement solid principles, a new paradigm that brings us Microservices, the common query responsive segregation that you can implement in your code. And if you are going to scale some part of your application, maybe you are going to have problems of performance with the monolith dependencies. And think in your code about failover, load balancing, automating scaling, and data separation, integrity and performance. So you need to test each part alone, make integration testing, and then see the whole scenario that you are going to have. And if you are going to change the architecture that you are working on, you can use the architectural clash. You can go to the page, and it's a little bit question that is going to help you if you are going to need to change something or not. And if you are not yet implementing continuous integration, continuous deployment in your organization, please do it. Before thinking about the evolution, evolve your architecture. So I think I have some 5 minutes. If you have any questions, I'm here for you. Of course. Of which one?
I think it was like 5 slides back or something like that. The one before the demo.
If you follow me in Twitter, I'm going to put the link of all the presentation in, maybe in the night, on the morning of tomorrow.
At the beginning, you said that you separated the UI from the backend through messaging, but the UI have to be responsive. So how you get the responses from the backend?
I explained it so fast. So what I do is to put a queue in the middle of the front end and the back end. So okay. What is going to, what I do is that in the front end that is based in Java. It's based in Java server faces, not in JavaScript yet. I start to put a message in the queue, and with Apache Camel, I implemented the request reply pattern. With 3 lines of code, I put a message, and the thread is going to be waiting until it finishes the process in the backend.
I see.
And it's going to.
So actually, it was asynchronous.
Yeah, it's asynchronous,
okay.
But it looks synchronous. So it gives you the picture that is synchronous. But what is really happening behind it is everything is asynchronous. So I start to batch all the requests in the backend, everything. And what gives me this, it gives me the chance to start to split the backend. Like every message is taken from a queue and is taking a message. It's easier to refactor the code in the backend without broke everything.
Okay.
So I start to split it, messaging and logic in smaller parts and in smaller modules.
So it will have been a too big step to go with REST.
Too big a start to split this huge monolithic.
Okay.
Even that my way is not going to finish with whole microservices architecture. I start to have small modules, small ER files, small Word files that is easier to maintain, easy to change, easy to deploy, and it gives me a wall between the business logic and the front-end logic that we used to join in the past.
And it was just an intermediary step before replacing this with
Before
REST.
to start to replacing and split the modules in the domain.
Okay, thank you.
So if we don't have many more questions, I appreciate that you be here, and thank you.
Thank you.